In this lecture, we'll see how we can make our dynamic array class a generic, so it can store any data type, not just ints. And this is really common practice. That's why all the data types in the system collections generic namespace are generics. The way we actually make our dynamic array generic is we add this notation after the class name. And this looks a lot like the notation you see when you create a list object to hold a particular type, because lists are generics as well. And we provide the type we want them to hold between the less than and the greater than. Here in the class definition, we actually put the same sort of notation, but this T stands for the type that we're going to add. The next change we make is here, where we declare an array of type T rather than type int. Then in the constructor, we create a new array of whatever type T is. Count stays the same. Our abstract methods all take in a T parameter rather than an int parameter. Clear works the same, and toString works the same. So we only need to make minor changes to our parent class to support making it a generic rather than just making it store ints. We make our unordered dynamic array a generic by using that same notation here, and it is still the child class of that parent class. Notice we put that notation at the end here as well. The constructor doesn't change at all. As I mentioned, add now takes a parameter of type T, but none of the rest of the code changes because it all works the same way. It's just adding an item of type T rather than an item of type int. Similarly, the remove method takes a parameter of type T and the rest of the code is identical. And index of has one other change. We include a parameter of type T, but you'll also notice that here, instead of using equal equal, I'm actually calling the equals method. So as long as the type T, that is the element type for everything we're storing in our dynamic array, implements the equals method, this comparison will work just fine to find the item when we're looking for it. Our ordered dynamic array actually has something new here at the end. So we're providing a constraint for the type that we can include in an ordered dynamic array. And we're actually saying that whatever type we want to put into this ordered dynamic array has to implement the comparable interface. And we're actually going to look at how we implement an interface in the next lecture. But the bottom line is the comparable interface says that the T type has to implement a compare_to method, and we need that compare_to method because we need to be able to compare two of the elements to decide the appropriate ordering in this ordered dynamic array. The constructor stays the same. T type for the parameter, and a change here. So instead of just comparing one element to another using less than, we use the compare_to method. And the way the compare_to method works is if this item is less than this item, then compare_to by definition returns a negative number. So this Boolean expression here is basically checking if the item at add location is in fact less than item, which is just what we were doing before. Remove works the same way it did before, except with T there. And index of works the same way as it did before, except that we use compare_to to see if we found a match, and we also use compare_to to decide which side of the subarray we should search next for the item. And the shift up and the shift down methods work the same way they did before with no changes. To recap, in this lecture, we learned how we can make a class a generic, and we also learned how we can add a constraint if we need a data type to implement a particular interface.